Okay, in this video, me and my team will be talking about a very important topic. This topic is very much involved in all areas of chemistry. Today we're talking about rate of reaction. Okay, that's it. Before we go over anything, let me tell you what rate of reaction is. To put it simply, rate of reaction is the change of concentration in a reactant or a product per unit of time.
But how do we know even the rate of the original reaction in the first place? Well, the best way to find it is through isolated substances. Usually in a reaction, when we dissolve it in a solution, obviously, it's going to be quite hard to see the product. But what's more important right now is know the initial rate of reaction. But we need to ask ourselves, how do we know what's our rate of reaction? Well, to put it simply, we must know how fast the reaction is happening. We can do so by seeing the product that is created by the reaction. A quick example would be calcium carbonate mixed with diluted hydrochloric acid. When both of them are mixed into water, those are the reactants, which creates three main products: calcium chloride, water, and CO2. Obviously, calcium chloride being a compound that dissolves in water is extremely difficult to be detected within the aqueous solution without further methods. Secondly, water in water cannot be detected. But the CO2 is quite easy, as it's a gas that will evaporate out of the water. So, with a device that will able to capture the rate of how much carbon dioxide is created, that will be the original rate of reaction under normal circumstances. But what is important in this case is how you can alter said reaction, whether hastening it or slowing it down.
In this segment, we'll be looking at the different factors that affect the rate of reactions. And the first one is pressure or concentration. Now I'm sure you're tired of hearing me and my friends speak, so let me have them demonstrate for you. This is chemical A, and those two are chemical B. Now let's put them in a container. For the chemical reaction to occur, we want chemical A to collide with the particle from chemical B. Now let's have them move. The particle of chemical A finally collided with the particle from chemical B. But it took a while, and we can speed it up. And to do that, we can increase the concentration of the reactant. So for this, let's increase the concentration of chemical B. Once again, let's have them move. In this case, the rate of reaction is faster. When we increase the concentration, we increase the amount of molecules of the reactants, whether it's chemical A or chemical B, for example. This means collisions between the molecules occur more often.
Look at what uni did to us. Eh?
Another factor for increasing rate of reaction is temperature. For one, temperature can increase the movement of the molecules, but what's more important is that a certain temperature is needed for even the reaction to start. For you can see in this graph, at like a base room temperature level, the potential energy to start a reaction is not enough. But if it's heated up, the potential energy increases. Then, when it reaches a certain point, the activation energy is reached and it can be converted to kinetic energy. And then with the reaction happening, potential energy drops as being used for kinetic energy, and we can get the product. And speaking of kinetic energy is also another factor that increases rate of reaction that is affected by temperature.
Let's take chemical A. Right now, chemical A is at room temperature. Let's see his speed. 3, 2, 1. This time, we increase the temperature by quite a lot. Let's see the speed of the particle from chemical A this time.
With the increase in temperature, the movement of molecules will increase as well, increasing the likelihood of them to collide, increasing their rate of reaction. For example, when both chemical A and chemical B are in increased temperature, their movement increases as well, as you can see. Then they will collide more likely, causing the chemical reaction to happen more rapidly.
Firstly, what is a catalyst, you might ask? In simple terms, a catalyst is a substance that increases the chemical rate of reaction without being consumed. Okay, but how? Remember the activation energy? So if normally a reaction requires this much activation energy, a catalyst would find another pathway that decreases the activation energy to something like this. Demonstration time. Let's take this reaction for example. The reactants will need to go to point B from point A for the reaction to occur. They would need to take this route, aka the pathway. But with the catalyst, we will find an alternative route to get to point B, which requires less steps. It's kind of like how Google Maps gives you a shortcut to a destination. So when the activation energy is lower, that means more particles have enough kinetic energy to overcome the activation energy, which means there will be more successful collisions, which increases the rate of reaction. Now, we'll quickly go over this factor. Essentially, some reactions just occur faster. This is because every reactant is different in nature, whether it's the type of bonds they have, or their structure, or even their physical state. These all affect the rate of reaction. The surface area, pretty simple, right? It's the surface of an object. So how does it affect the rate of reaction? Let me show you. So for this example, this is substance A. Now, substance A is submerged in water, and it will take about 20 seconds for it to fully react with water. But if we were to split substance A into two, his surface area would be greater than if he were in one piece. And if you were to split him even further, his surface area would then increase even more. This would now take way less time for the reaction to be complete. When we increase the surface area, the water now has more access to substance A. And this means there's more interaction between substance A and water, which means there will be more successful collisions between the particles, increasing the rate of reaction. So in short, more collisions equal faster reactions,
increased concentration,
Temperature, surface area,
and catalyst. I hope you guys understood the concept of rate of reactions and the factors that affect it. Thank you guys so much for watching. See you next time.